हरिः कर्ता।
Now let's look into the second technique in outlier detection, that is IQR, interquartile range method. So IQR is a statistical measure used for outlier detection in a data set. It represents the range between 25th percentile and the 75th percentile. The 25th percentile is called as quartile 1, and then 50th percentile is called quartile 2. That's nothing but mean. And then the 75th percentile is called as quartile 3. So IQR represents the range between the 75th percentile Q1, quartile 1, and the 75th percentile Q3 and Q3 of the whole data. Q3 of the whole data. Here when we say 25%, it's a frequency. If you have 100 data points, then 25% of 100 data point falls below quartile 1, that is 25, and 25 plus 25% total 50% of data falls below quartile 2, that is 50 data points. Then 75% of data falls below quartile 3, that is 75 data points. Okay, that's what the quartile 1 and quartile 2, quartile 3. So if you put it in very simple terms, the IQR, this interquartile range, that's Q3 minus Q1, this interquartile range from here to here. Okay, this one. So this interquartile range captures the middle 50% of data. You see that 25% plus 25% total, middle 50% of data it captures. The middle 50% of the data it captures, excluding the lowest 25%, this one, and quartile 1, and excluding the highest 25% of the data, these two. Excluding these two, the middle 50% of data will be captured by IQR, interquartile range. So IQR is calculated by subtracting 25th percentile quartile 1 from the 75th percentile quartile 3. So this is what the formula to calculate IQR. IQR is equal to quartile 3 minus quartile 1. So once the IQR is calculated, it can be used to identify outliers in a data set. The IQR defines a range within which most of the data points in the data set are expected to fall. Data points that fall outside of this range are considered potential outliers. So let me put it in. So this is IQR method. So here the condition how it detect outliers using to detect outliers, the whatever data points that falls outside a range. So the IQR range, whatever that falls outside this IQR range are called outliers. Now if you don't give the specific condition, or normally the IQR defines a range within which most of the data points in the data set are expected to fall. Data points that fall outside data points that fall outside outside of this IQR range are considered potential outliers. So to detect outliers using IQR, a common approach is to define a threshold. So this is the main one. Normally, if you take this is a normal method. But if you want to use the actual method to detect outliers using IQR, that is a threshold. That is a threshold through threshold. So to detect outliers using IQR, a common approach is to define threshold. Threshold as a multiple of the IQR. Threshold is equal to multiple of IQR. So typically, it could be threshold could be is equal to 1.5 or 3 times of the IQR. That's what I meant here. So any data points that fall above or below this threshold are considered outliers. So any point that falls above or below of this threshold are considered as outliers. That's it. So now let's take an example and understand this better. So NumPy has been imported, I guess. Nothing, I don't need to import again and again. So now let's generate a random data set. So data random dot normal, and then LOC is equal to 0, then scale as usual is equals to 1, size is equal to 100, and this is our data. And now let's calculate the percentiles. Let's calculate the quartile 1 and quartile 3. So let's calculate the 25th percentile, so which is nothing but the Q1 is equal to np dot percentile and data, and it's 25. So this is what is our Q1. So Q1 quartile 1 is a value below which 25% of the data points fall. That's it. Then let's calculate the 75th percentile, that's Q3. So Q3 is equal to np dot percentile and data, it's 75. So let me check the Q3. So Q3, the value Q3 quartile 3 or 75th percentile is a value below which 75% of the data points fall. So now we have quartile 1 and quartile 2. Now it's time to calculate the IQR. So IQR is equal to quartile 3 minus quartile 1. So IQR. So it's 1.31. The range of IQR is 1.31. So under which the central or middle 50% of data points falls. Okay, that's what the IQR. So now let us define a threshold. Now let us set a threshold for identifying outliers. So threshold is equal to, I'll take just 1.5 multiples of outliers. So the multiples of IQR. So let me take a threshold of 1.5 times of IQR, and this is what the threshold I got. So now I need to identify outliers because I have defined whatever has to be done so far. Everything has been done. Now let's identify outliers. So outliers is equal to data of data which is lesser than Q1 minus threshold threshold and data which is Q3 plus threshold. So outliers are nothing but the data which is lesser than Q1 minus threshold and the data which is Q3 plus threshold. So it's literally says below Q1 and above Q1, above Q3. Below Q1 minus threshold, it's nothing but below Q1, and then above Q3, keeping the threshold in mind. Threshold negative when it comes to below Q1, and threshold will become it will be added when it comes to the Q3 above. Okay, now let me execute. Okay, there is some issue. So, and okay, U function or not supported. Okay, closing parenthesis. Here it started. That's it. So outliers, and here is what the outlier you found out. This is the only outlier you have. Okay, so this is how we identify outliers using IQR method.